All right, welcome to Unit 2. We are in Lesson Number 1, which is titled Learning Targets, Special Angle Relationships. You should have the appropriate note sheet. Once again, if you do not, please log on to your Teacher's Fusion page and print out a copy before you get started. All right, so we're going to be focusing on angles tonight, and as I said, special angle relationships. So let's start with some vocabulary. The first angle we're going to talk about is called a right angle. We've all heard of a right angle. It is indeed a 90-degree angle. And one thing to point out in this first diagram right here, 90-degree angle, and please make note that, as always, we need to indicate that an angle is a right angle by drawing that right angle symbol, that little box in the corner, just like we were doing in Unit 1 when we were drawing perpendicular lines and perpendicular bisectors. Okay, and anytime you see that little box, it's telling you that that is indeed a 90-degree angle. Why is that important? Well, we can use that information to find the measure of missing angles. Take a look at the second diagram. As you can see right here in the corner, we see a 90-degree angle symbol. So what that's telling us is that this big angle I'm going to outline right now in red is a 90-degree angle. It is a right angle. But if you notice in the middle that this big angle is broken up into two smaller angles. And together, those two angles add up to 90 degrees. So we can use that information to find the measure of this angle right here, which for right now I'll just label X because that's what we're trying to find. So if the whole angle adds up to 90 and this little piece is 25, what I can do is I can simply set up an equation if I want to put the two angles equal to 90 degrees. Okay, once again, angle X, which is this guy right here, plus the small angle right here, adds up to my big angle of 90 degrees. So I can set up a quick equation and solve for it. Really what I'm going to do is subtract 25 from 90, and I get 65. Okay, so that I know that this angle right here is 65 degrees. And I can just double check quickly, 65 plus 25 is 90. Awesome. All right, let's take this one step further. Please take a look at the next diagram. If you notice, we don't know any angle measures, but we are given some information. We know that the big angle adds up to 90 degrees because we see the symbol. We do know that this angle right here is 2x minus 7. And we know that this angle right here is x plus 1. So if we're instructed to find the angle measures, the first thing we need to figure out is, well, what is the value of x? So we can use the fact that both of those angles together add up to 90 degrees. So I'm going to set up an equation. I'm going to take the first angle, 2x minus 7, and to it I'm going to add the other angle, x plus 1, and it's equal to 90. All right, and now I'm going to solve my equation. Let's start by combining like terms. I'm going to square all the x's. I'm going to circle the numbers. I'm going to combine my like terms. All right, so I know that 2x plus x, I have two x's, and I add one x, I get 3x. If I have negative 7, and I'm adding 1 to it, that brings me to negative 6. Okay, now I can continue solving this equation. I'm going to go ahead and add 6 to both sides. I get 3x is equal to 6. And then my last step. All right, now let's take a look back. If we're to find the missing angle measures, have we done that? Not yet. We know what x is equal to, but we need to go back into each angle and see what we have to do to get the final answer. So this angle is x plus 1. Okay, well if x is 32, I know that it's going to be 32 plus 1. So I'm just substituting x in to both equations. All right, 32 plus 1 is 33. So that tells me that that angle is 33 degrees. Likewise down here, I have 2 times x minus 7. So 2 times 32 minus 7. And I'll use my order of operations. 2 times 32 is 64. Subtract and I get 57. So that's telling me that this angle is 57 degrees. Now, to make sure that you did your algebra correctly, you can quickly add these two numbers together, and they should equal what? You got it, 90 degrees. All right, let's continue on. If you notice you are having trouble or difficulty solving equations, please talk to your math teacher and come in for some extra practice. All right, our next vocabulary word is complementary angles. You may remember hearing this in the past, but complementary angles are two angles that add up to 90 degrees. They add to 90 degrees. So those first examples we saw, let me scroll back up, these are examples of complementary angles. Here you have two angles, these two right here, that add to 90 degrees. You also have a set of complementary angles right here. Those two angles added to 90 degrees. One thing to be aware of is the angles do not have to be adjacent, meaning they do not have to be connected like our first two examples. Okay, you could have two angles that are completely separate from each other. But if it's indicated to you that indeed they do add up to 90, then you know they're complementary. Okay, so in this example, I have a 35-degree angle and a 55-degree angle. They're not adjacent, meaning they're not connected. But when you add those two numbers together, they add degrees. So they are complementary angles. Same thing down below, supplementary angles are two angles that add to 180 degrees. They can be connected. They do not have to be. Here's an example of two angles that are not connected that are supplementary. 60 and 120. When I add them together, I get 180 degrees. You also can take a look at a pair that are connected, which we see in the example below. Okay, here's a pair of angles that are supplementary and they are connected. They're adjacent. All right, so keep in mind we can have it both ways. So our next word is linear pair. A linear pair is a specific type of supplementary angle. It's like this one I drew right up here. A linear pair are two angles that form a line and they add to 180 degrees. A straight line has a measure of 180 degrees. It's like a half circle. Okay. A linear pair are supplementary angles that are connected. So as we see right here, this little angle right here, this guy that's 25 degrees, I'm just going to color in the middle so you can see it. And this angle next to it, this one right here, I'm coloring in red, they add up to 180 degrees. They're a linear pair. They make a line. So I can find the measure of this red angle by subtracting 25 from 180, just like we did with this complementary angles in example number 1. When I do that subtraction, I get 155 degrees. Okay? And then taking a look at our second example, once again, it's a linear pair because the two angles form a straight line, and they are connected right here. They share that common ray. They share a common side. That's what we mean by adjacent or connected. So I can set up an equation to figure out x and to ultimately figure out the measure of each angle. Okay, how do I set up my equation? Well, I know that the linear pair adds up. They add to 180. You can use that information to help you. So I have x plus 1 plus, because I'm adding, 2x minus 7, and together those equal 180 degrees. So now I'm going to solve my equation. Square your variables, circle your numbers. X plus 2x is 3x. 1 minus 7 is a negative 6. Okay, add 6 to both sides. I get 3x is equal to 186. If I divide both sides by 3, I get x is equal to 62. All right, just like before, though, we're not done. We need to find what each angle is measures to. So if x is 62, this one is 62 plus 1, giving me an angle measure of 63 degrees. And over here, I can sub in and do 2 times 62 minus 7. All right, and when I do the math, I get 124 minus 7, also known as 117 degrees. And do a quick check. 63 plus 117 does indeed add to 180, so I am good to go. All right. Up next, we have vertical angles. Vertical angles are two angles that are created by two intersecting lines. They share a vertex but are non-adjacent, so they're not next to each other. The angles are congruent. Okay, so always remembering they are congruent. We'll come back to that in 1 second. Let's take a look at this diagram. I'm going to outline the vertical angles. So I'm going to look at this one here that has an angle measure. Notice if I look at it sideways, it makes the letter V. Its vertical angle, they share a vertex, meaning this point right here. They're not adjacent, so it cannot be this guy and it cannot be this guy because those are adjacent. They're next to it, sharing a side. Its vertical angle is over here. It's two V's that touch. They make a bow tie together. And the directions tell me they are congruent. That means equal measure. Okay, so if this one's 25 degrees, that means this one has to be 25 degrees. So how can we solve a problem knowing we have vertical angles? We'll take a look at the next example. We see over here two vertical angles. Okay, I'm going to trace them out so I can see they indeed form V's. The vertexes are touching. And I'm going to set up an equation. Well, if the angles are congruent, if they have equal measures, I can set the two equal to each other. And I'm going to solve. So I'm going to go ahead and move my variable one side. 2x minus x is x. Those cancel. One left over. And I'm going to move my numbers to the other side by adding 7. So x equals 8. And once again, substitute that back in. So up here I have 8 plus 1, which is 9. And over here I have 2 times 8 minus 7, which is also 9. Good. Those two numbers should be equal because once again they are congruent or equal measure. If they're not, go back and check your work. All right, let's go ahead and flip the page. Here are your directions. When I'm done reading them, please pause the video. Do this exercise on your own. When you're ready, press play and check out your answers. What we would like you to do is to use the definitions from the previous page to classify the following angles as vertical, linear pair, complementary, and or supplementary. So you're going to take a look at the angles and decide what angle relationships you notice. And I would just like to point out that some of them may be multiple answers. Okay, so scroll down here, take a look, and here's how you're going to do it. Let me show you one of them. Letter A, looking at angle 1 and 2, right here. Angle 1 and 2. Decide what relationship there is between angles 1 and 2. Well, they form a linear pair because they're right next to each other on the line. So I'll go down here and write my answer, linear pair. And if they are a linear pair, they must also be supplementary. Okay, because a linear pair means they form a line which is 180 degrees. Okay, so please pause the video, complete B through H, and then press play when you're ready. Okay, welcome back. Please check out the answers, compare them with your own. If you have a question, go back to your vocabulary sheet, see if you can see why the answer is what it is. If not, please circle and bring your questions to class. All right, let's move on. The next two vocabulary words we're kind of going to blend together. Parallel lines and transversal. Well, a quick reminder, parallel lines are two lines that will never, ever, ever, ever intersect each other. And what's so great here is when I'm just going to name mine for right now, L and M, just so they have names, okay? When we take a transversal and we put that line through the two parallel lines, we're going to form some really special angle relationships. Let me show you what I mean. So a transversal is a line that crosses two parallel lines. It can be anywhere. So here's an example of a transversal. It's a line that just crosses between them. Okay, that is your transversal. And like I said, when a transversal crosses, special angle relationships are formed. Let's jot that down. When a transversal crosses parallel lines, special angle relationships are formed. Eventually, we will be using this information to work backwards as well, meaning we can take angles and prove lines parallel knowing what we know. We will get into that later on though. Okay, so let's take a look at the next page. Let's dive into what these angle relationships are. Okay, so the first one we're going to talk about is called same side interior angles. They are also called consecutive interior angles. So consecutive or same side. Okay, consecutive, same side, meaning in a row, they're next to each other. Interior, meaning inside. Think about the interior of your house. So we're looking for two angles that are on the same, they're right next to each other. They're on the same side of that transversal, and they are inside the parallel lines. Okay, so same side of the transversal, inside the parallel lines. So in this example, we're going to be looking at the 75-degree angle, and then we're going to be looking at this guy right here. I'm just using marks to show you the two angles we're looking at. Okay, now you'll notice that as of right now, my two marks are different because what I know about the measures of these is that the angles add up to 180 degrees. Okay, once again, I can use those words to tell me they add to 180 degrees. So if these two together add to 180, I can subtract this one from 180 to find this angle measure, which would be 105 degrees. Okay, so here are your set of same side interior angles, also called consecutive interior angles. I would just like to point out you have another pair over here. Okay, these two angles right here would also be considered same side interior angles. All right, so we can use this information to once again solve an algebra problem. Taking a look over here, these two angles are indeed on the same side of that transversal, and they're sandwiched in between the parallel lines. So they are same side interior angles, and they add to 180 degrees. So here's my equation. I literally add them up so they equal 180 degrees, and I can solve. Okay, I will combine my like terms. 5x plus 3x gives me 8x. I will combine my numbers. 5 minus 25 is negative 20. And then I can continue to solve. I'm going to go ahead and add 20 to both sides. I get 8x is equal to 200. Divide by 8. So x is equal to 25. Okay, thinking again, well, I need to go back and find the angle measure, so I will have to plug that number back in. So I will start with this top angle right here. So it'll be 3 times 25 minus 25, which when you do the math, you should end up getting 50. So that's 50 degrees. This one down here is 5x plus 5. So I have 5 times 25 plus 5. And then when I do that math, I end up getting 130 degrees. And a quick check, 130 plus 50 is indeed 180, so I'm good to go. All right, my next set of special angles are called alternate interior angles. Okay, once again, interior meaning inside. Alternate meaning on opposite sides, which you see right over here, opposite sides of your transversal. So we're looking for angles that are on the inside of your parallel lines on opposite sides of the transversal. So here we have one, and here's my other one. The two blues are a pair of alternate interior angles, and it tells us that the measures are congruent. Remember, congruent being the same, they are equal measure. So if this angle is 83, this angle is going to also be 83 degrees. All right, let's take it one step further. Those of you ready for a challenge? Right here I have a linear pair. Okay, so if the little one is 83, I'm going to subtract that from 180 and get 9. Well, guess what? I have another set of alternate interior angles, these two right here. Okay, so there are two sets of them in this problem, just to be aware of. Okay, let's take a look over here. Once again, using our information to solve the problem. Read carefully. The angles are congruent. They are equal. Use that information to set up the equation. 5x plus 5 is equal to 3x plus 43. All right, I'll subtract 3x on both sides. I get 2x plus 5 equals 43. I'm going to subtract 5. I get 2x equals 38. So therefore x is equal to 19. Come back over here and I plug that in. Let's start with this angle. 3 times 19 plus 43. And when I go ahead and I do that math, I get 100 degrees. Okay, now this guy should also be 100, so this will be a good check. 5 times 19 plus 5. And when I do that math, I do also get 100 degrees. So I'm good to go. All right, so all the angle relationships we've seen so far, if you've taken note, there's 3 different scenarios. They can add up to 90 degrees, they can add up to 180 degrees, or they are equal to each other. Our next one is alternate exterior angles. Okay, we should be getting comfortable with the vocabulary now. Alternate meaning opposite sides of the transversal. And then exterior meaning outside. Okay, think of exterior of your house. So they are not between the 2 parallel lines. They're on the outside of them. So if I take a look at this example, here's this one. Down here will be my alternate exterior angle. It's Buddy. And then looking up here, I know that once again they are congruent. They are equal to each other. Okay, for those of you that are ready, we can also figure out the measure of this one, which is our other set of alternate exterior angles, by subtracting 121 from 180. And when I do that, I get 59. So this one has to be 59 because they're alternate exterior angles, so they are congruent. So let's come over here and set up our equation. Once again, they're equal to each other. So 52 minus x is equal to 3x plus 4. And it does not matter which one is on which side of the equal sign. Okay? All right, so I'm going to go ahead and add x. I get 52 is equal to 4x plus 4. I'm going to subtract 4. Bring it over here. I'm going to get 48 is equal to 4x. Divide both sides by 4, and I get x is equal to 12. All right, so let's finish that up. 52 minus 12, I get 40 degrees for this angle. So I should get 40 up here. 3 times 12 plus 4 does indeed get me 40 degrees. So they are equal to each other. All right, the last angle relationship we will look at for today is called corresponding angles. This one's a tad bit different. There are 2 angles that are on the same side of the transversal, okay, same side. And if one angle is in the top of one parallel line, then the second angle is on the top of the other parallel line. Meaning, here, this angle is on the right side of the transversal and it's on top of the parallel line. So its corresponding angle, Buddy, will be right here. And they are congruent. So it is 97 degrees. We also see, I'm just going to put dots in them for color, for informational purposes. I'm not going to go through angle measures right now. But this one's corresponding angle will be right here because they're on the left side and they are on top of the parallel lines. Likewise, this guy's would be down here. They're on the left side and below each parallel line. Okay, and the last one is right here. I'm going to put a blue dot there just so you can see it. That is also a pair of corresponding angles. Okay, so there are 4 sets of corresponding angles in the diagram, just to be aware of. All right, so let's go ahead and make an equation. Same thing, they are equal to each other because they are congruent. So I have 3 times x minus 9 is equal to 2 times x plus 1. Now, this one's a tad bit different because we have to do some distributing first. So I'm going to go ahead and distribute my 3. I got 3x minus 27. Distribute my 2. I get 2x plus 2. And I can continue solving. Subtract 2x. Leave me with x. And I can add 27. Leave me with x is equal to 29. So of course I can go back in and now do the math. 2 times 29 plus 1. 2 times 30, which gives me 60 degrees. And I have 3 times 29 minus 9, which is 3 times 20, which is 60 degrees. All right, so we've looked at all of our angle relationships. Quick recap. looking at these angle relationships are formed when you have two parallel lines or more cut by a transversal. Okay, so same side interior angles, they are congruent. They are on the same, I'm sorry, they add up to 180 degrees. They are on the same side of the transversal in between the parallel lines, and they add up to 180. Alternate interior angles. They are on opposite sides of the transversal. They are both in between the parallel lines, and they are congruent. Alternate exterior angles. They are on opposite sides of the transversal. They're both outside of the parallel lines, and they are also congruent. And the last one is the corresponding angles. They are on the same side of the transversal in the same location on each parallel line, and they are congruent. All right, let's go to the last page. All right, we're going to go ahead and finish up with just a quick little bit of practice, just identifying angle relationships. Okay, so once again, what you're going to do is you're going to pause the video, go ahead and look at each angle down here, A, B, C, D, all that good stuff, and tell me their angle relationship. Are they alternate interiors, alternate exteriors corresponding, same side interior, or none? Okay, you may notice that some of them are linear pairs and nothing else, but for right now, we're not asking you to identify those. One quick change, please go ahead and change G to angles 1 and 6. All right, go ahead, pause the video. When you're ready, press play and look. All right, go ahead and take a look at the answers. So we were just identifying angle relationships based on the previous page. Okay, please bring your notes to class and any questions you have. We will be doing practice with identifying the angle relationships and solving algebraic equations based upon knowing the special angle measures, whether they're congruent, add up to 180 degrees, or add up to 90 degrees.